Okay, so here we have the second part of our little series on graphing motion. This deals with a speed time graph. So this is the second kind of graph that we might do related to motion. So in this case, we're not plotting the position of the object over time, according to time, but we're plotting its speed or its velocity according to time. Now, the only difference between a speed time graph and a velocity time graph would be that a velocity time graph can go negative. It can go into the negatives down here, whereas a speed time graph cannot have negatives because speed cannot be negative. Velocity can be pluses or minuses, but speed can only be pluses. Right? Anyways, this particular graph is done as a velocity time graph. So if we look here, several things are labeled, including this phrase that you are not yet familiar with. Probably you are actually familiar with it, but we haven't discussed it in these videos, and that's this phrase, acceleration. We'll talk more about acceleration in its own video shortly, but in this case, acceleration, you just need to know that it's related to changing velocity. So when velocity is changing, that's called acceleration. All right. And you can also decelerate. Deceleration, that's negative acceleration. It's when acceleration, you're slowing down. All right. Positive acceleration is speeding up. All right. So what are we looking at here in this graph? We are looking at the motion of an object. Let's say it's a car, or maybe a cart in the lab. So if the cart in the lab is moving, say, away from the person who pushes it, then that would be perhaps a constant velocity. A constant acceleration. So it's increasing its speed as it moves away from the person. And then it's going to move at a constant velocity, or a constant speed, and then it's going to slow down and stop. Now it's important to know that on this kind of a graph, a velocity time graph, stationary motion has to be a straight line along the bottom. All right. Anyway. So what we have here would be the motion of an object as it accelerates, increases its speed, then moves at constant speed, then decreases its speed back to 0. All right, so that's what it would look like if it was graphed here. Again, vertical axis, we have velocity. All right, and then the horizontal axis, we have time. All right. Now, as with the distance time graph that we were looking at in the previous video, the speed time graph has several interesting features of it as well. So we're going to look first at this one, which is this flat line, which you remember, for a distance time graph, this means that the object is not moving. However, for a speed time graph, this means that the object is moving. It's moving at a constant speed or a constant velocity. All right, if we plotted it over here, it would be some value at which this object is moving at that speed or velocity, if you will. All right. That's it for this, pretty simple. Now here what we have is a steadily changing speed. All right, and how would we graph that? We would graph it like this. So on this axis here you would have meters per second, and then on this axis, the time axis, we would have seconds. All right, so the speed here is changing, but it's changing at a constant rate. So we call that a constant acceleration, or a steadily changing speed. All right, your speed could be changing at a not steady rate, and in which case that would look something like this, or it might even look like this. Right, but a straight line means constant acceleration, or a steadily changing speed. All right. And then the last thing, which is a special thing, this is a really interesting case, a special way of using a speed time graph is what you see here. So in this case, the speed is decreasing from 10 meters per second down to 0 meters per second. And it decreases its speed down to 0 in 20 seconds of time. So here's the interesting thing. The question is this: how far did it travel? What was its distance? All right, so that's the question. Here's how we find it. All right, we're going to zoom this out, give ourselves a little space to work, just push that off to the side. All right, so it turns out that in order to find the distance, I'll give you the formula here. Distance is equal to speed times time. All right? So that's the formula for finding distance. You'll notice speed times time on this graph here, well, that would be speed is the vertical axis, time is the horizontal axis. As it turns out, the distance traveled, I'll just cut to the chase, cut to the point. The distance traveled on a speed time graph, you can find it by finding this area. The area here under the graph, that area. So this is a triangle. The area of a triangle is equal to 1/2 times the base times the height. Right? So that's from math. All right. Let's get rid of that equation up at the top for now. There we go. So 1/2 base times height, that's going to be, in this case, 1/2 20 times 10. So that equals 1/2 times 20 times 10. 20 times 10 is 200. Half of that, we're going to get 100 meters is the unit of distance on this graph. So the total distance traveled by this little cart, or whatever it is that's moving, is going to be 100 meters. Now, probably that's not going to happen in a laboratory. Possibly this is a vehicle being driven on the road. But in any case, if that's the speed time graph for this object, you find the area under the graph for the time you're interested in. That will give you how far that object has traveled during that period of time. Pretty darn cool. All right, again, something that you're going to get some practice with in class. This is going to be really important that you can use this. It shows up on almost every test for IGCSE, and of course we'll be quizzed on it or tested on it here in class as well. All right, great. Hope that was useful. You can always rewatch it if you need to.